In this video, we're going to learn how Babylonians used their numerals to represent numbers. Their numeral system was quite advanced in ancient times. Babylonians could use them to do complicated calculations like solving quadratic equations. We will also show how the numerals were used in geometry. The picture here is a list of Babylonian numerals representing 1 to 59. The numerals are mainly formed by two wedge-like symbols, one pointing downwards and one pointing towards the left. You can see that the method of representation is pretty systematic. For example, if there are two wedges pointing towards the left and 7 pointing downwards, then it represents 27. You may wonder how Babylonians represented numbers greater than 59. In fact, the method is similar to the decimal number system that we are using today. The crucial concept is the so-called place values, which means that any number is formed by a number of digits where each digit has its value depending on its position. For example, consider the three-digit number 255 in a decimal number system. The digits 2, 5, and 5 obviously have different values. The rightmost digit 5 actually means 5. However, the middle digit 5 is not 5 anymore, but 5 times 10 equals 50. Generally speaking, the middle digit is for counting the number of tens. For the leftmost digit 2, it means 2 times 10 squared equals 200. That is to say, the digit counts the number of hundreds. Therefore, 255 can be expanded like this. This is the so-called decimal expansion. Obviously, in a decimal number system, the place values of digits are powers of 10. 10 is what we call the number base. For example, the place value of the leftmost digit of a 9-digit number is 10 to the 9th power. Using place values, we can express any number in terms of a finite number of symbols in a very economical way. Let's see the following example of Babylonian numbers. According to the table of Babylonian numerals we have shown you before, the digits are 7, 44, and 20 respectively. The number base of the Babylonian numeral system is 60. So the place values of digits are all powers of 60. Sometimes the Babylonian numeral system is described as a sexagesimal place value system. If we want to find out what number the above Babylonian number represents, all we need to do is to expand it like this. As you can see, the Babylonian number is actually 27,860. Our decimal number system can do more than counting with integers. We can also use it to express non-integers with the help of a decimal point. Here is a very simple example. 25.7 in a decimal number system means 2 times 10 to the power of 1 plus 5 plus 7 times 10 to the power of minus 1. The decimal point is used for separating the integer and fractional parts. The digits on the right-hand side of the decimal point have negative powers of 10 as their place values. That is to say, the left-hand side is the fractional part. For a general place value system, the point having the analogous function as decimal point is called the radix point. Babylonians did use the numerals to represent non-integers in a similar way. But unfortunately, Babylonians didn't have any symbol for radix point. Therefore, in the previous example, the Babylonian number 7, 44, 20 can also possibly mean the following: 7 times 60 to the power of 1 plus 44 plus 20 times 60 to the power of minus 1, or 7 plus 44 times 60 to the power of minus 1 plus 20 times 60 to the power of minus 2. The position of the radix point has to be guessed from the context. For the sake of clarity, we will use the semicolon as radix point. For example, the Babylonian number 2:636 has the expansion like this. That is to say, it actually represents 2.11. Besides the absence of a radix point, Babylonians also didn't have any symbol for 0. Instead, a blank space was used to mark the non-existence of a digit in a certain position. However, this is far from satisfactory because sometimes it's hard to tell whether two digits are separated by one or two blank spaces. Again, for the sake of clarity, we will use our usual 0 symbol to denote such a blank space. For example, the Babylonian number 3:036 means the following. It turns out that it represents 3.01. You may wonder why the Babylonian numerals look like wedges. It is because the Babylonians wrote numbers and words on the tablet of unbaked clay using the cut tip of a stylus, which left wedge-shaped marks on it. This is sometimes called the cuneiform writing, as shown in the photo below. A few ancient Babylonian clay tablets that recorded mathematics survived. One of them is particularly famous. It is called YBC 7289, as shown in the photo below. The values of the Babylonian numerals on the tablet are indicated on the photo. Some of them are on the diagonal of a square, and some of them are on the side. It looks like the Babylonians used the numerals to do a geometry problem. Do you know what all these Babylonian numbers mean? We have already gone through all the things that you need to know about Babylonian numerals. What you need to do next is to complete the quiz on Babylonian numerals on the next page. After the quiz, you are going to explore more deeply about the YBC 7289 clay tablet and answer some questions about it. Finally, you will be asked some questions about how Babylonians calculated the volume of a geometric solid based on another clay tablet called BM96954. This is the end of the video. Thank you.